Support for today's Heat Treat Radio episode is provided by Heat Treat Today's AEROSPACE print magazine. Subscribe to receive a free hard copy in March at www.heattreattoday.com/subscribe. Welcome to Heat Treat Radio. With this episode, we're kicking off a special series called Lunch and Learn with Heat Treat Today, during which esteemed heat treat expert Dan Herring, the heat treat doctor, joins Doug Glenn, the publisher of Heat Treat Today, and various members of the team to lay down some heat treat basics. In this episode, we're going to be talking about thermal processing versus heat treatment. We hope you're able to use this training for yourself and others. Let's get started.
So Dan, I want to turn it over to you. Just give a context, though, of what we're going to be talking about. As you just mentioned before we hit the record button, we're pretty heat treat centric in our world, but there's a lot of other thermal processes that go on that aren't exactly heat treat. We talk about some of them in our publication, not all. So what we'd like to do is turn over to you just to talk about the difference between heat treating proper and thermal processing, generally speaking. So Dan, welcome, and thanks for educating us.
Well, thanks, Doug, and good afternoon, everybody. First of all, for everyone listening, if you will, I hope to cover again the basics, providing information without confusing everyone. If there are any questions as I go along, please don't hesitate to ask them. I think it's always better to have an interactive back and forth discussion on things. And you're absolutely correct, Doug. We live in a heat treat centric world. And I'm going to start off in familiar territory by discussing a little bit about heat treating. And then we're going to move into the differences between heat treating and thermal processing. Now, to give a simple definition of heat treating, simple yet complicated at the same time, is heat treating is the controlled application of time, temperature, and atmosphere to produce a predictable change in the internal structure, that means the microstructure to metallurgists, of the material being treated. Now, the interesting part is that heat treating is predictable, which is why metallurgists exist in the world. It is controlled, which is why heat treaters exist in the world. And the darnable thing about heat treating is it happens inside the metal or the material. And unfortunately, you can't see the changes that are taking place. Let me give you an example, if I can. I'll hold this up. I don't know if people can see it that well, but what this is a helicopter transmission gear. And if we were manufacturing this particular gear, one of the things we would do to measure if we were successful, or to see if we were successful, is to measure the dimensions of the gear that we were actually taking and manufacturing. But in the world of heat treating, because the changes happen inside the material, it's very difficult to know if the part is good or not. But heat treating has the ability, as we say, to vary the mechanical properties, the physical properties, and the metallurgical properties of a material. The problem is that we can change them either for the better, or as most heat treaters know, we can change them for the worst. That's why there's something called quality control and quality assurance. But I'm drifting away from the main point. So in the world of heat treating, with that definition, the controlled application of time, temperature, and atmosphere to produce a predictable change in the internal structure of a material, not only are we heat treat centric in this industry, we are often steel or iron and steel centric in this industry.
Mhm.
Metallurgists tend to be either ferrous metallurgists, specializing in irons and steels, or non-ferrous metallurgists, specializing in things called aluminum, or as the British and Europeans would say, aluminium, titanium, and some of the superalloys and things of this nature. But the idea being the fact that there's a lot of different materials that can be heat treated. We often limit ourselves, if you will, but there are parts of our industry that heat treat, for example, precious metals. There, the golds, the silvers, the platinums, things of this nature. There are also parts of our industry that deal with copper and brass. There are parts of our industry that deal with ceramics, which deal with powder metal, if you will. So one of the things as heat treaters we have to remember is that even under just the heat treat umbrella, there's a lot of different disciplines out there. There's a lot of things that we cover and we look at. There's a lot of different materials that are processed. And again, we think in general as heat treaters, and probably incorrectly so, we think about what are called semi-finished goods. What we think about are parts that are manufactured from steel or aluminum, titanium or copper, or powder metal. We think of automotive parts, aerospace parts. We think of something as like weapons or military equipment, ammunition, firearms. We think of agricultural products, farm implement products, and things of this nature. So one of the things we have to be aware of is that there's a whole world outside of our comfort zone. And that's something that we're going to explore today. So before I go on, does that make sense to everyone? Or has anyone got any questions about the heat treatment side of what we do?
Yeah, no, I think that makes sense. You mentioned on the inside of the part that things can't be heard, can't be seen so much. We also, I assume the heat treating, and you probably will get to this, Dan, I assume that also includes surface treatments, or would that be something different?
No, that's we'll talk a little bit about the difference between surface treatments, and they fall into an area probably referred in general as coatings and things of this nature.
Okay.
But that's a good question, Doug.
Yeah.
Plating and coating and things of this nature. Also, one of the things about heat treating that seems a little bit possibly confusing is that heat treaters consider processes like brazing, which is a joining process.
Right.
Also, they think of soldering, which is a low temperature joining process, as heat treatments. And similarly, we think of sintering, and we think of heat treatments of powder metal products, or we think of heat treating of, we think of powder metallurgy as falling under the subject of heat treatment, because we think so much about sintering. But sintering is a bonding or a diffusion process.
Right. Yeah.
So heat treaters think of heat treatment, they think of brazing, and they think of powder metallurgy, all combined into that big umbrella.
Yeah.
For any brazers that are listening, or any powder metal people that are listening, they probably died of cardiac arrest at this moment in time. But in general, that's what heat treating does, is it considers those separate entities as part of it. But let's go on and look at the fact that I could say to you, as I said, automotive components, gears, bearings, aerospace components and things of this nature, landing gear transmission boxes and things of this nature, fasteners, screws, nuts, bolts, farm implement equipment. Those are things that commonly come to mind. People don't often think, for example, though, of things like jewelry, which is something that is commonly heat treated or processed, if you will, more on the thermal processing side. A lot of electronic materials are also thermally processed. A lot of castings and things done in the foundry industry. But as I said, we think of semi-finished goods. We're a semi-finished goods centric, heat treat centric world. But there are other worlds out there, and let's kind of talk about them. But mill practices, or what we call primary metals, are another area that's covered, interestingly enough, under heat treating. Yeah. Because in steel mills and things of this nature, you'll find soaking pits, for example. In aluminum processing facilities or aluminum foundries, you might find solution heat treating and aging ovens and things of this nature. So there are, in a very broad or general sense, there is heat treating also done on the mill or the material production side of things. And again, unless we're in that industry, we don't tend to think about it that much. So we have to. But if I also said to you that things like cosmetics are being processed, not heat treated, but thermally treated, if you will, or things like cement or minerals and raw ore materials and things, these all fall in the category of now thermal processing. So let me try to give everybody just a feel for what the different categories of thermal processing are. The number one category, of course, is heat treatment. We've got to put a plug in. There's another thermal process. And by the way, thermal processes are also confused a little bit because we use heat or we use cold. Those are both thermal processes. For all the heat treaters out there, we do things like deep freezing, and we do things like cryo treatments, cryogenic treatments. Those fall in the umbrella of heat treating, but there are other deep cooling or cooling processes that fall under this umbrella of thermal processing. But besides heat treatment, thermal processing consists of a few areas which you're maybe familiar with, and then again, maybe you're not that familiar with. One of them is calcining, which I often call the drying of powders, if you will. This can be in the form of ores, it can be in the form of minerals, it can be in the form of coke, it can be, which is a coal byproduct, if you will. It can be in the form of cement. So there's drying processes that occur under thermal treatment, which is in the area of calcining. There's also a big category called fluid heating, where what we're doing, and by the way, air is a fluid, as well as water and liquids are fluids. So we can turn around and do things like chemical processing, which is done at elevated temperature. I had a client that was producing mayonnaise, and the mayonnaise is held at 180 degrees Fahrenheit. It's a thermal process, if you will. Distillation. We won't talk about alcohol much in the world, I will only comment that all of you think this is a bottle of water, but you could be mistaken about that. The idea is the fact that fluid heating, calcining, drying, smelting, metal heating in general, curing and forming, which is done a lot on ceramics, on paints, paint drying and things of this nature. And there's just in general other methods of heating. I'll give you a simple example. Waste incineration. We know that our trash is burned at ultra high temperatures to reduce emissions, if you will, but avoid going into landfills, or worse yet, dumping it in the ocean and believing that somehow it won't return to our ecosystem. But incineration is an example of a thermal process. So there are quite a number. There are literally hundreds of thermal processes that are occurring all the time that we don't in general think very much about. We tend as heat treaters to think, and by the way, heat treating is typically divided into two general categories: processes that soften a material and processes that harden a material. So in the category of softening, we think of things like aging. We think of things like annealing. We think of things like normalizing, or even stress relieving. In other words, taking the stress out of material is a softening process.
Tempering as well, Dan, would it be in that?
Well, tempering is in a sense could be considered a softening process. It's a good one. I consider it more a softening process than a hardening process, but it's typically so intimately linked with hardening and case hardening that people think of it as a hardening process. But hardening and case hardening, tempering is another something you've heard. And then, of course, the brazing, which is a joining process, the soldering, the sintering, which is a bonding process, homogenizing when we talk about aluminum, solution treating when we talk about aluminum. Solution treating is actually not a hardening process, interestingly enough. It's the aging or the precipitation hardening process after the solution heat treatment that's actually the hardening process. But the idea of the fact is we're very familiar with those terms. We're less familiar with coke ovens or waste incinerators or distilling facilities or things of this nature. We're not used to processing resins or composite materials, even though they're autoclaves that use a combination of high pressure and temperature to form some of the composite materials that are used in the aerospace industry. So the way I like to think about it is there's a giant umbrella, which is called thermal processing. And under that umbrella is a small segment, maybe not so small, called heat treating. And then heat treating is divided into semi-finished goods and raw materials or primary goods. And then it's subdivided into irons and steels and non-ferrous alloys. Now, in my day, when you graduated university, you graduated with a degree in metallurgy. Today, you become a material scientist, which means that you're dealing with composites, ceramics, electronic materials, a whole series of materials outside the realm of just iron and steel and aluminum and titanium, if you will. But the other thing that's very interesting about our industry in general is probably the aspect of energy usage. The thermal processing industry in general, and this is a rather stunning number, uses in round numbers about 38% of the energy produced in the United States. Now think about that as a number. Of all the energy consumed by people in the US or in Canada or in Mexico or anywhere else in the world, 2/3 of it or greater, 80% of it almost, is used in thermal processing. I'm sorry, not 80%, 40%.
40, yeah.
40%, I apologize. So 40% is used by the thermal processing industry. About 25% is used by transportation, and the rest, another 20% or so, is used by residential. And then there's about 15% used in what we call an other category. But in thermal processing, which is also true in heat treating, about 80% of the energy comes from natural gas.
Yeah.
And only 15%, round numbers, comes from electricity. So we have to realize that we're not only, as heat treaters, heat treat centric, iron and steel centric, aluminum centric, but we're also natural gas centric. Those are staggering numbers to consider. And the reason for it, the reason we're natural gas centric, not only in the heat treating industry, but in the thermal processing industry as a whole, is simply because natural gas is the cheapest energy source available right now.
Right.
And these numbers, although they apply specifically to North America, can also apply, if you will, to the world in general. The numbers vary a little bit throughout the world. They may be different in Europe, different in Asia, but not so much that it varies so greatly.
When we return, Dan is going to open up the floor to the Heat Treat Today team for questions. But first, I want to tell you a little bit about our sponsor, the Heat Treat Today March AEROSPACE print magazine. This magazine, like all other Heat Treat Today print magazines, is free to subscribe to, and you can even access it online if you leave your hard copy at home. In this AEROSPACE 2022 edition, we're talking pyrometry, vacuum furnaces, how-tos, and much more. Subscribing to receive the print magazine is simple. Whether you're already signed up to receive some Heat Treat Today resource or not, just go to www.heattreattoday.com/subscribe or go to the website and click subscribe. Fill out the form with your info and select print so that you can receive these magazines at your home or your office. But be sure you are subscribed in the next few days so you get the March issue. Again, head to www.heattreattoday.com/subscribe. Now, back to the episode.
So what I've tried to cover, and I realize I haven't left a lot of room for questions here, and I apologize for that. We'll get into those momentarily. But I've tried to give you the idea that heat treating is a very important part of a much larger industry that services the manufacturing community.
Yeah.
And let's open it for discussion from anybody.
Yeah, that sounds good. Any of you have questions at all?
I did actually have one.
Sure.
I thought I think it was very helpful in understanding everything, and the idea that thermal processing is an umbrella and heat treatment is just a part of that was really clicked for me. I was wondering if you could talk about calcining, right? Calcining.
Sure.
A little bit more and what that process actually is.
Sure, but before I do that, I want to mention one thermal process that I forgot to mention, because I have a number of clients that work in the baking of cookies and bakery product. And because I've consumed a few of those in my life, I don't want to forget the baking industry as part of
baking, brewing, even brewing.
Absolutely. By the way, the Brewing Hall of Fame is located here in Chicago, unless I'm grossly mistaken.
That's
Now,
all right.
before we get too far afield, let's talk about calcining a little bit. But the idea is the fact that a number of powders, whether they be ores or whether they be things like cement or various minerals, are often processed in what we call a slurry. They're processed in a form in which they're either cleaned or washed with water or with different chemicals. So as a result, you have a wet mixture of a mineral and let's say water, or in some cases they can be different chemicals, if you will, that go to either clean the minerals or dilute the minerals or things of this nature. But to go to further processing of those minerals, you have to dry them and put them into a form that they can be used. If this makes any sense, and let's take cement as an example, it's no good to keep the cement in a slurry, because what's going to happen to the cement? It's going to dry and harden.
Yeah.
So what you have to do to send it to the consumers is you have to dry the powder, if you will, the Portland cement, deliver it to the end user, who will then add liquid to it to once again form it or turn it into liquid cement, if you will. So calcining is really, in simplest terms, to answer the question directly, I always consider it a powder drying process. And
Yeah,
that's,
Dan, any idea why they call it calcining? I've always wondered this.
well, in the old days, I believe that limestone, which is calcium carbonate,
Gotcha. Okay.
and so calcining, calcium from the calcium carbonate.
Gotcha.
I think that's where the name originally came from.
Yeah.
It's a good thing
So-
to look up, however. That'll be my homework assignment.
There you go. There you go. So it just is another example of a thermal process. It's certainly not heat treat. Just down the road from where I live here, north of Pittsburgh, we have a lot of sand and gravel places. And believe it or not, there is a large, I would call it a horizontally oriented, like a screw furnace. It's a cylinder and it just rotates. And inside it's heated up, and they're just simply burning off the moisture so that they can get the materials, whatever it is they're harvesting out of the earth there, get it down to a certain level of moisture so they can, again, process it. So I don't know whether that's sand and gravel, but that's just another area where they pay. Here's another one. And Dan, I want you to hit on glass, if you don't mind, in a minute.
Of
But
course.
here's another one where thermal processing is used, which you might not think of it, and that's in the manufacturing of paper production. They've got to actually dry the paper, and they've got these, you wouldn't think of it, but they're passing paper through flame, actually between flames, not actually in the middle of the flames, but between flames, simply to dry paper before it goes on to these huge rolls. And then one last comment, Dan, is we often talk about energy intensity and how much energy it actually takes to process to perform a certain process. One of the highest thermally intense processes that is used is not so much a heat treatment, but it's actually the manufacturing of concrete, believe it or not.
Mhm.
Very, very high energy intensity. It takes a lot of gas in this case to produce concrete. But Dan, if you don't mind, could you hit on glass production? Because, we're all looking out windows here, and the manufacture of glass is a thermal process.
Absolutely it is. But before I do that, quickly, that rotary drum that you
Rotary drum.
saw, the one with the screw inside it, if you will, that helps move the powder, if you will, or the sand and gravel through, is a very typical calcining furnace.
Yeah,
You
yeah.
Rotary drums are also used in the heat treatment industry to process screws and fasteners, nuts and bolts, small products, if you will, typically. But yes, paper is a good example, but glass furnaces, where the glass is actually brought up and the sand and other elements, if you will, are melted into glass. Very disconcerting. You may not, you may find this interesting, but roughly the walls on a glass furnace, I've seen 10, 20,000 pound glass furnaces, and the walls are something like 4 inches thick, holding back all that molten glass, if you will. But again, you're taking glass is basically silicon dioxide. It's sand, if you will, is a major component of it. In colored glasses, you add different chemicals. Like, for example, if you want to form a bluish colored glass, you might add a copper oxide, for example, which will change or tint the glass to a different color. You've heard of leaded glasses, for example. In the old days, you added lead to a glass or to glass to make it, again, more formable, if you will. But yes, glass furnaces, or the manufacture and production of glass, is very energy intensive, as well as cement, as is the production of aluminum, by the way.
Yeah.
Which is basically uses electricity, which is why all the aluminum facilities are located either near hydroelectric or thermal energy, like in Iceland, for example, where you have geothermal energy, which is used to heat and produce electricity. So, but yes, glass is definitely an example of a thermal process as well. Glass is interesting because we don't necessarily do a lot of heat treatment of glass, but you may have heard of glass to metal sealing, where we're actually taking a glass and sealing it into or onto a metal component. Like, for example, the sight ports of burners, where we look in to see the flame. Those sight ports are made by glass to metal sealing. Yeah. But in general, yes, the melting and production of glass is a thermal process.
And the fact that it's a thermal process, Dan, correct me if I'm wrong, because I could be wrong on this, but cell phone, right? Your glass on the front of that, the reason it is actually quite strong and won't break is because it's been thermally processed, a tempering process of some sort, I believe. Correct me if I'm wrong, but isn't it the thermal process that can make a glass really, really difficult to break?
It is, plus the fact that a glass is a quasi-solid, as we say. It's a solid, but it's really not. It has more characteristics of a liquid, which again makes it more ductile or resistant to things like, it makes it more shock absorbing, for example.
Gotcha.
But yes, cell phones and cell phone glass is something I've got to do some more research on.
Yeah, they've got some stuff called Gorilla Glass, I know. That's anyhow. Any other questions? Anybody else have questions? Bethany, Abby, Karen, anything? Lauren? Well, Dan, thanks a lot. Yeah, I just want to recap a couple things for our team here and for other people that might be listening. When we talk about heat treat, right, which is again what we're centered on, it's helpful for us to know what processes, materials, and things that includes, and what processes and materials that doesn't include. And that's why this conversation on thermal processing versus heat treat is helpful for us. The way I like to describe it to our team and to most of the people who would be reading our publication or listening to this podcast is typically we're not involved. Heat treat today is not involved with the making of steel, but almost everything else after the making of steel, we would deal with. Almost everything, okay? So we don't really do the steel making. Steel making, however, is very much a thermal process, but we just don't cover it. There are other publications that cover that. And we are very much steel centered. We do aluminum as well. However, in the aluminum world, we actually do deal with aluminum making for reasons that basically have to do with the temperature range. It's the temperature range isn't quite as high with aluminum making that is with steel making. So we do some of that, not a lot with aluminum making, but a lot with after aluminum is made. We do a lot of that, homogenizing, annealing, solution heat treating, that type of stuff. So that is us. In heat treating, we define things like brazing. Yes, even though it's a joining process, we tend to cover it. Soldering, we don't tend to cover because it tends to be a lower temperature. We also, Dan didn't mention it, but I'm sure he would, is welding. It's a joining process, but it's not exactly anything that we cover either. It's not what we consider to be heat treating. There is another joining process that we didn't cover. Maybe we can hit on it briefly next time, and that is a diffusion bonding, which, to be quite honest with you, I haven't done a lot of study on it, so it would be interesting to know what that is. I know it's done in vacuum and under high pressures, I believe, but things of that sort. So at any rate, that's what we mean when we talk about heat treat. It's primarily steels, aluminums, titaniums, and typically not steel making, and probably not titanium making either, but aluminum making and everything downstream from that tends to be us. And our temperature ranges tend to be, very generally speaking, 800 degrees F and above. Or as Dan mentioned, we can also do some things in the cryogenic range, which are sub-zero temperatures. So that is us. Everything that falls outside of that, we would consider to be a thermal process, which is a lovely, lovely thing, but just not our cup of tea. So
Look at this, Doug, a whole new business opportunity for you.
that's it.
And
Dan, thanks a lot.
with that, I'm extending myself beyond metallurgy, so I'll quit there.
That's fine. Now, Dan, we really appreciate it. We look forward to more of these. We are going to try to do other topics. Again, what I would call heat treat 101 type topics, our lunch and learn series with Dan Herring, the heat treat doctor. So Dan, thanks a lot. We appreciate your time.
A pleasure, everyone. Thank you.
Thanks, Dan.
Thank you.
We hope you enjoyed listening to today's episode with Dan Herring, the Heat Treat Doctor. Heat Treat Radio is on Apple Podcasts, SoundCloud, iHeartRadio, Podbean, and the website www.heattreattoday.com/radio. If you'd like to get in contact with Dan, head over to www.heat-treat-doctor.com. That's heattreatdoctor.com with hyphens in between heat treat and doctor. You can also email Dan at dherring, that's HERRING, at heat-treat-doctor.com, or email me and I can put you in touch. My email is bethany@heattreattoday.com. Do you have a new or interesting idea that you want to hear discussed on Heat Treat Radio? If so, let me know and we can be in touch. Or if you'd like to sponsor a future episode, let me know. My email is bethany@heattreattoday.com. As a final tip, heattreattoday.com does have more resources that range from heat treat basics, like what you heard today, to technical case studies. Try searching 18 heat treat technical resources on heattreattoday.com to see what I mean. Heat Treat Radio would like to thank Heat Treat Today's AEROSPACE print magazine for sponsoring this episode. Subscribe to receive a free hard copy in March at www.heattreattoday.com/subscribe. This and every other episode of Heat Treat Radio is the sole property of Heat Treat Today and may